So, quickly getting started with the final test of the year, the Unit 3B tests. We've got the AP test coming up and then our semester exam project. But for now, this is the last video that I'll be making. We'll hop right in. How do you find the period of the tangent function? So just remember that period for tangent function is pi over b. And I'm writing with my mouse on my desktop this time if my handwriting's a little worse than normal. But so for example, if I had f of x equals -7 tan of 5x, my b value is what's in front of the x. So my period here would be pi over b, which is pi over 5. So write an equation, and I'm going to go kind of quick. More in-depth explanation is on the review key written out. Write an equation in x equals form for the vertical asymptotes, and remember the asymptotes here. This is where your vertical asymptote that you find goes, and it's going to be plus your period. So to find the vertical asymptote, you start with where the parent function is. So let me go to Desmos. I'll show you this. So if I have y equals tan x, the parent function here, I know, so x equals pi over 2. Draw a dash line there. It'll work. So you can see that parent functions on a tangent has its first vertical asymptote on the positive side at pi over 2. So that's why we use pi over 2 here. So vertical asymptote, you use the parent function's vertical asymptote and set it equal to your horizontal component, which is what's in parentheses. Because everything in parentheses is what's affecting you left and right. So just to see a visual of this, y equals tan of, say, we're using 4x. You can see that compared to my original function, this has shrunk down a lot, which is why my first vertical asymptote moves. It's shrinking by a factor of 4. So to solve this, I divide by 4, and it's going to give me pi over 2. Keep change, flip that. So one of my vertical asymptotes is going to be at pi over 8 equals theta. So pi over 8 goes here. And then for my period, remember, that's what question 1 asked. So period is going to be pi over b, or pi over 4. So pi over 4. 3. This is drawn a little bit funky. These should be separated right here on, or not, they printed funky. When I go to Delta Math and create these, it has them in separate lines, but for some reason when I go to print them, it always does this. So you can separate them there. That's a is greater than 0, a is less than 0, b is greater than 1, and then b is between 0 and 1. So the function f is graphed below. If f of x equals a tan of b, parentheses, x minus pi over 2, close parentheses twice, circle the correct inequalities for a and b. So for the a value, so for a, that's just the number in front. So here is the parent function of tangent, okay? And really, there's just a 1 in front, right? So 1 tan x. Doesn't change anything. So in this case, if it looks like this, my parent function is going up, and my a value is greater than 0. But if it's negative, it looks like this. So that's where I get this from. So if I have a positive a, it would be going like this right here instead. Okay. So because it's facing this way, the a value, a is negative. Like we can tell by the graph, a is negative. So I would circle a is less than 0. And then my b value, remember my b value is going to be 2 pi over period. I mean, not 2 pi, that was for sine and cosine. So b equals pi over period. And then my period is from asymptote to asymptote. So you can go here to here, Or if it's on the x-axis nicely, you can go from here to here. And that gives me a distance of pi over 4. So pi over 4. So that's my period here. Here as well. You can get it for both. So keep change flip. The numerator is pi over 1 times, flip it to 4 over pi, which gives me 4. And then to evaluate tan here, what I will do, let me quickly copy this. So pictures. Let me bring a unit circle in. Remember, you have a cheat sheet, so you can just, to do this, you can have your unit circle ready to go. Let me zoom in some. Okay. That's not what I meant to do. There we go. So tan of 2 pi over 3, remember tan is y over x, so at 2 pi over 3, it's y over x. And remember, you can ignore the 2's because they just cancel out. So at 2 pi over 3, I'm at square root of 3 over negative 1, which will just simplify to negative square root of 3. And then for 5 pi over 4, I'm right here, y over x. Remember, the bottom's just will always, the denominators will always cancel out. Sorry, I'm trying to quickly get this done on my planning. So I have negative the square root of 2 over negative square root of 2. That's my y over my x, and that's going to divide out to positive 1. So write the restrictions for arc sine, arc cosine, and arc tangent. The easiest way to remember this is your circles and what halves they are. So boom. So this right half of the circle is arc sine, and it's also arctan, and cosine is the top half. This comes from 3.9 in your notes. So arc cosine. And if you wanted the full restrictions, like what these restrictions are saying, is my range is going to be from negative pi over 2 to pi over 2. For cosine, it's going to be 0 to pi. And tan's the same thing as arc sine, except the endpoints are not included. So parentheses instead of brackets. Now, let's evaluate each one of these. So I'll just paste it on the side and delete it. We don't need it. So actually, it'll be nice to have for later anyways. So if I'm evaluating arc cosine of square root of 3 over 2, I know for arc cosine, I can only be working with this top portion of the circle. So on the top portion of the circle, of the unit circle, when is it positive square root of 3 over 2? Well, remember cosine's x values, that happens right here. So this is just going to give me pi over 6. Now for arc sine, there's 2 ways to do it. I like to, when I'm doing arc sine and arc tangent, remember that I can slide the negative to the front. It's because arc sine and arc tangent are odd functions, so that means I can rewrite it with the negative out front. And then just do negative and then evaluate arc sine of 1/2, which is also pi over 6. So negative pi over 6. The negative was out front. That was at pi over 6. So negative times pi over 6 is negative pi over 6. And also, if you wanted to do the negative 1/2, negative 1/2 is down here. And if I start at 0, I went backwards by negative pi over 6. Okay? And then arctan of, let me erase these. Arctan of negative 1 over the square root of 3. I'm looking for, you can do the same thing I did with sine. The only one you can't do it with is cosine. So I can slide the negative to the front. Negative tan, arctan, sorry, of 1 over the square root of 3. And then I'm looking at arctan here, and 1 over the square root of 3. So remember, if I ignored the 2's, 1's on top, my y over my square root of 3. So that happens at pi over 6. So negative times pi over 6 again. And if you wanted negative 1 over the square root of 3, remember arctan is only in this right side of the circle here. So I'll go back, and negative 1 is right here, and square root of 3 is right here. So I went backwards pi over 6 again. So negative pi over 6.